Good morning. In the previous video, I explained about normal distribution, the definition, properties, and applications. Now, I am continuing some of the problems related to normally distribution. If x is normally distributed with mean 2 and variance 0.1, then find probability of mod x minus 2 greater than or equal to 0.01. So you need to find the value for this probability of mod x minus 2 greater than or equal to 0.1. So first of all, you should know how to split this modulus x minus 2 and which is greater than or equal to 0.01. So this I am writing as 1 minus p of mod x minus 2 less than 0.01. So in the limits chapter in your intermediate, we have modulus of x minus a less than delta. This delta is the neighborhood of a. How we can change this modulus? A minus delta less than x less than a plus delta. So in the place of a, you have as 2. In the place of delta, 0.01. So substituting in this, you will get 2 minus 0.01 less than x less than 2 plus 0.01. So by subtracting this, you get 1.99. By adding this, you are getting 2.01. So in the place of this modulus, I have written like this: 1 minus p of 1.99 less than x less than 2.01. So whenever the probability or in terms of x values, you have to convert this x as standard variate. So that is z is equal to x minus mu by sigma. So standard normal variate is z equal to x minus mu by sigma. So in this here we have x value, one is 1.99, other one is 2.01. So substituting x value as 1.99, then what we will get? The standard normal variate value 1.99 minus 2 by 0.1, that is the z value minus 0.1. So other you are taking other one x as 2.01 and finding z value, you get 0.1. Now here the x lies in between 1.99 to 2.01. So we have converted into standard variate, and that one is that z is lies in between minus 0.1 to 0.1. So this is the normal curve. In that this is a symmetrical line. In this case z is always 0. So one z value is here negative, another z value is 0.1 positive. So one I have drawn this side and one I have drawn this side. So this is from 0 to left side you will have negative, right side you will have positive value. Now so what you have to find here, so the area of this minus 0.1 in between minus 0.1 to 0.1, that you need to find. So for that I have written like 1 minus area from 0 to 0.1, and here 0 to 0.1. Why I have not written here minus 0.1? Why? Because these are symmetrical curve, so you can write both as positive. By the area we are taking as positive. So here from 0 to 0.1, what is the area given in the table values? So this is 0.1. What's the value? At 0.1 you will have z value as minus, z value at 0.1 you will have the area 0.0398. So we have here double times the area, so 0.0398 is added and subtract with the 1, you get the probability of modulus x minus 2 greater than or equal to 0.01 value as 0.9204. Okay, like the same way another question related to this probability. So this is another model. In this model, you will have two different types of questions. One is if you know the z value, you have to find the area. If you don't know the z value, then from the area you can find z value. That is another model question. Now here, this is the second question. If x is a normal variate, find the area capital A, that is first one, to the left of z is equal to minus 1.78. That is the first question. Second question, to the right of z is equal to minus 1.45. And the third one, corresponding to minus 0.8 less than or equal to z less than or equal to 1.53. And the last one, to the left of z minus 2.52 and to the right of z 1.83. So according to these z values, you need to find the areas. So first question, so to find the area to the left of z is equal to minus 1.78. So first you have to locate where the z value on the graph, normal curve. So this is the normal curve. In this, always this symmetrical line is z is equal to 0, and here in the first question it is given negative. So I have drawn the left side of that symmetrical line, z value as minus 1.78. So now what I need to find here, to the left of z. So what is given? To the left of z. So what is to the left of z? So this is z value. So right side is this part, left side is this part. So this part area you need to find. So this is the shaded part, this part area you need to find. But actually this part you can find from the table values. That is from 0 to 1.78. So what is the value for that? Z is 1.78. So this is 1.7 and here it is, so what it is 1.7 and this one is 8. So 0.4625. So at z value 1.7 and 8th column wise you have to check, and that value is 0.4625. So substitute in that. This one is 0.4625, but I need this shaded part. Actually you know this complete half of that curve have as 0.5 area. So from that 0.5 area you subtract with this area, you get this shaded part area. So required area, what should be taken? The half part area, this is 0.5, and this unshaded part area to the left of that symmetrical line should be subtracted, and you will get the required area as 0.0375. Like second one, to the right of z is equal to minus 1.45. So the second question is to the right of z is equal to minus 1.45. So here I have drawn this line, the negative value. So z is equal to minus 1.45. So to the right means this total area comes right side of this z value. So you need to find all these values. Already you know this area is 0.5. Okay, and I need to find only this shaded part. So how you can get this shaded part? So you have to check z value by taking 1.45. So what is that value? 1.45, 0.4265. This is the area. This one is this part is 0.4265. So I need the right side of z area. So this total I need. So you have to add these two, will get as 0.9265. This is the second one. Next, third one, corresponding to minus 0.8 less than or equal to z less than or equal to 1.53. So this is the question given, corresponding to minus 0.8 less than or equal to z less than or equal to 1.53. So z have the limits minus 0.8 to 1.53. So how I can draw that? Here it is a normal curve, and here minus 0.8 located area value of z, and this is 1.53. So I need this in between this shaded part. So first you have to find from 0 to 0.8 how much is the area, and then from 0 to 1.53 how much is the area from the table values. So these are the areas. By adding these two areas you will get the required area, which is in between 0.8 to 1.53. And the next, what is the fourth question? To the left of z is equal to minus 2.52 and to the right of z is equal to 1.83. So left of z is equal to minus 2.52. So I have located z value minus 2.52 here and z value 1.83 here. So to the left of z is this shaded part, to the right of 1.83 is this shaded part. Are you getting? To the left of minus 2.52 is this shaded part, to the right of 1.83 is this shaded part. So what should be taken now? I need to find this area, this area. So how I get this area? From 0 to 2.52, the area is 0.4941. From 0 to 1.83, the area is 0.4664. This is 0.4941. So how could I get this shaded part? By subtracting with 0.5. So if you subtract 0.5 to this number, you will get the left of z is equal to 2.52, this one. Like the same, by subtracting with the 0.5 to this number, you will get this shaded area. Okay, but the question is given to the left of z and to the right of z. So to the left of z and to the right of z. So and is given, so you have to conclude the answer with the required area as adding those two shaded areas. So that is 0.0395.